So our goal is going to be to solve some trigonometric integrals that are fairly common. And to do that, I need you to recall some things from trig. The first thing that you will need to know is the one we call the half angle identity. That's probably the most often substitution that you're going to make. On your handout, if you're looking at your old trig identities, we call that the half angle because one is half of the other. Trig functions are transcendental. That means that half does not go into the angle. If at some point you want to go back on the proof of these, I'll be happy to show you where they came from. I think where you're at right now, you need to know this. The other trig identity that you should know is that the cosine squared plus the sine squared equals 1. I'd expect you to know that the sine is, the tangent is sine over cosine. I'd expect you to know that secant is 1 over the cosine. One of the more important integrals that we do do I need to scroll back? Is the sine squared. So briefly, if you think back to what the sine looked like, this is a horrible time, right in the middle of developing a trig proof. So if we were to graph the sine, that was sine. If you graph sine squared, it looks sort of like a series of half circles. anytime I start measuring power, like out of your speakers or out of electrical transmission, I can't really graph the sine. I need to graph the sine squared so that when it averages out, I get a good answer. So we tend to talk about the mean of this as an RMS, for root mean square. It's actually the square root of 2 of the value, which is why we get the root mean. I'm not going to go into where it comes from totally. When you're evaluating your speaker systems, you're going to buy a speaker system for a car. They're going to tell you the RMS value. They're not going to tell you the actual value. They're going to give you a root mean square. If you're going to buy a speaker system for your computer, that's how they're going to evaluate that. If you're buying a generator for your house, they're going to give you an RMS so that it's a sine wave value. So that's where it comes in as an important value. Let's talk about how we're going to integrate it. In case you weren't clear, folks, the reason I talked about that was to tell you why anybody cares. You need to substitute. You can't integrate the sine squared. There's no easy way to do it unless you know this trick. Instead of keeping it as the sine squared, turn it into something without squared values. We can distribute. Trick. This is the trick. If you don't know to substitute that, you won't be able to get it.
Is that a Y or a 4? I.
That is a 4. When you integrate a d theta, you get theta. When you integrate a cosine, you get a sine, but this is a cosine of 2 theta. That will integrate to the sine of 2 theta. Now you can either go back to doing this with the chain rule where you do a substitution, or you can see that that 2 becomes a 1/2 out there, so it's cancel out. If it was a 3, you'd have to have a third. If it was a 4, you'd have to have a fourth. We're going from 0 to pi over 4. This is in radians. In calculus, you're always in radians. would help if you recall that the sine of pi over 2 is 1. That's the answer you get. If it had been a cosine squared, I would have made that substitution with the half angle for cosine squared. So let's look at another one.